The universe is not just vast, it's alive with mysteries that laugh in the face of our understanding. Every time we point a telescope at the darkness, it throws back riddles written in starlight, cosmic puzzles so strange they rewrite the textbooks. And here's the wild part: some of these enigmas aren't just distant curiosities. They're colossal, impossible structures, galactic ghosts, voids that should not exist, filaments of matter stretching like spiderwebs across billions of light years. We're talking about 25 cosmic anomalies so bizarre they make black holes look ordinary. These aren't just astronomical oddities, they're cosmic rule breakers, shredding what we thought we knew about physics, gravity, even reality itself. Picture standing on a shore at night, staring at an ocean where the waves move in patterns no sailor's ever seen. That's where we are right now with these structures. Take the Great Attractor, for example, an unseen force dragging entire galaxies toward it like some cosmic siren song. Or the Boots Void, a billion light-year bubble of nothingness where the universe forgot to put galaxies. These aren't just empty spaces or clumps of matter, they're existential glitches, and each one whispers the same tantalizing question: what if everything we've assumed about the cosmos is wrong? This video is your boarding pass to the edges of known space, where the maps fade and the real adventure begins. We'll unravel the secrets of structures so massive they bend space-time itself. Some might be fossils from the Big Bang, others could be clues to dimensions we can't perceive. And here's the kicker: these mysteries aren't locked away in some distant future. They're out there now, waiting, challenging anyone daring enough to look up and wonder. So buckle up. By the end, you won't just see the universe differently, you'll feel it breathing. Deep in the direction of the constellations Hydra and Centaurus, something massive is pulling. Not just a star or a galaxy, but thousands of them, including our own Milky Way, racing toward it at over 2 million kilometers per hour. This is the Great Attractor, a gravitational nightmare so powerful it bends the paths of entire galaxy clusters like rivers flowing toward a hidden waterfall. And here's the cosmic irony: we can't even see it directly. It's hidden behind the thick curtains of interstellar dust in what astronomers call the zone of avoidance, a region so choked with debris from our own galaxy that visible light gets swallowed whole. It's like trying to study a lighthouse while standing inside a sandstorm. But through X-ray and radio telescopes, we've glimpsed enough to know this isn't just a cluster of galaxies. The math doesn't add up. The pull is too strong, too focused, as if something even more colossal, something we've never seen before, lurks in the shadows. Some theories whisper of a supercluster of galaxies so dense it warps spacetime like a bowling ball on a trampoline. Others suggest an unfathomably large concentration of dark matter, the universe's invisible scaffolding, clumped together in ways we've never observed. And then there's the unsettling possibility: what if the Great Attractor isn't the final destination? What if it too is being dragged towards something even bigger, a chain of cosmic puppets pulling each other into the unknown? One thing's certain: this isn't just about gravity. It's a reminder that even as we map the cosmos, the universe keeps its greatest secrets just out of sight, taunting us with questions written in the motion of stars. Whatever lies at the heart of this enigma, it's rewriting the rules of the game, and we're just beginning to play. The Boots Void isn't just empty space, it's a cosmic crime scene where most of the galaxies have gone missing. Stretching 330 million light-years across, this vast spherical desert contains less than 60 galaxies where there should be thousands. If the universe were a crowded concert hall, the Boots Void would be the inexplicable empty circle where no one dares to stand. At first glance, you might think this is just a fluke, a random bubble of nothingness. But the numbers defy probability. Standard models of cosmic structure predict voids about 1/10 this size. The Boots Void is so abnormally large that spotting it in simulations is like finding a swimming pool in the Sahara. How does a region this big end up almost completely empty? Astronomers have two leading theories, and both rewrite our cosmic story. The first points to the aftermath of inflation, that split second after the Big Bang when space itself expanded faster than light. Tiny quantum fluctuations during that era might have stretched into enormous underdense regions, leaving behind voids like this one. It's as if the fabric of space-time had air pockets baked into it from the very beginning. The second theory is far more speculative and unsettling. Some researchers suggest such extreme voids could be evidence of advanced civilizations harvesting galaxies over unfathomable timescales. While this idea leans heavily into science fiction, it underscores how little we understand about the universe's true possibilities. After all, if a civilization could harness the energy of entire galaxies, why wouldn't they eventually reshape their corner of the cosmos? Here's what makes the Boots void truly humbling. Even its emptiness teaches us. The way light from distant galaxies dims as it passes through reveals secrets about dark energy. The eerie silence challenges our models of galaxy formation. It's not just a hole in space, it's a mirror reflecting back all the gaps in our knowledge. And somewhere in that darkness, the universe might be laughing at our attempts to explain it. Stretching across 10 billion light-years, nearly a seventh of the observable universe, the Hercules-Corona Borealis Great Wall isn't just a structure. It's a cosmic paradox. This gargantuan filament of galaxies, discovered in 2013 by mapping gamma-ray bursts, defies every expectation of how matter should be distributed in space. Imagine throwing a handful of sand into a swimming pool and watching it form a perfect line instead of scattering. That's the level of improbability we're dealing with. According to the cosmological principle, the universe should look roughly the same in every direction at large scales. But this wall, with its galaxies clustered like beads on an infinite string, mocks that assumption. It's not just large, it's unsettlingly organized, as if the universe played a prank on our textbooks. Then there's its slightly smaller cousin, the Sloan Great Wall, a mere 1.4 billion light-years long, yet still massive enough to shake cosmological models. Discovered in 2003 using data from the Sloan Digital Sky Survey, this structure resembles a spiderweb of superclusters, each one a neighborhood of thousands of galaxies. Together, they form a filament so vast it could bridge the gap between our Milky Way and Andromeda 60,000 times over. But here's the twist. According to current theories, structures this size shouldn't have had enough time to form since the Big Bang. Gravity moves at the speed of light, and 13.8 billion years shouldn't be enough for matter to clump into such intricate, sprawling patterns. The existence of these walls forces astronomers to confront two possibilities. Either our understanding of cosmic evolution is missing a critical piece, or there's something fundamentally flawed about how we measure the universe's age. Some theorists speculate that these structures could be scars from the universe's infancy, when quantum fluctuations during inflation stretched into colossal wrinkles. Others suggest darker, more exotic explanations, like alternate dimensions bending gravity in ways we can't yet perceive. What's truly humbling is that both walls are likely just the beginning. As telescopes peer deeper into the cosmos, we keep finding structures that push the boundaries of what's supposed to be possible. They're not just rewriting the rules, they're tearing up the entire playbook. And with every discovery, the universe seems to whisper, "You haven't even seen the strange parts yet." Hoag's object is the universe's way of showing off, a galaxy so perfectly symmetrical it looks like someone painted it onto the cosmos. At its heart lies a golden yellow core of ancient stars glowing like a cosmic ember. Surrounding it, a near-flawless ring of blue young stars dances in precise formation, separated by a dark gap so clean it could have been carved with celestial scissors. Discovered in 1950 by astronomer Arthur Hoag, this 1 in a billion anomaly defies every expectation of how galaxies should look. Most spiral galaxies, like our Milky Way, have arms swirling from their centers. Elliptical galaxies are blobs of stars without clear structure, but Hoag's object, it's a celestial bullseye, and no one knows exactly how it formed. The leading theory involves a galactic collision, a smaller galaxy piercing through a larger one like a bullet through smoke. The shockwave could have triggered star formation in a perfect ring, while the original core remained intact. But there's a problem. No visible remnants of the intruder galaxy exist. It's like finding a shattered window without any evidence of the rock that broke it. Another idea points to resonance effects, where gravitational forces organize gas into stable orbits, creating that striking ring. Think of it like dropping pebbles into a pond. Under the right conditions, the ripples could freeze into a permanent pattern. What makes Hoag's object even stranger is its isolation. Most ring galaxies have companions or show signs of recent chaos. This one floats alone, pristine, as if it formed in some exotic experiment rather than the violent universe we know. And while a handful of similar objects have been spotted, like the rare Leda 174,000, none match its eerie perfection. Some astronomers wonder if it's a glimpse of an entirely different galactic evolution path, one where mergers and turbulence somehow sculpted order from chaos. Here's the kicker: the gap between the core and the ring isn't truly empty. Faint streams of stars stitch the two together, like invisible threads holding the mystery in place. These whispers of structure hint that Hoag's object might be older than we think, a relic from a time when the universe played by different rules. Every time we study it, the questions multiply. Is it a fluke, a prototype, or proof that we've barely scratched the surface of how galaxies can exist? One thing's certain: in a cosmos full of chaos, Hoag's object is a mesmerizing exception, a celestial sonnet written in starlight, waiting for us to decode its verses. Rising from the heart of our galaxy like ghostly hourglasses, the Fermi bubbles stretch 25,000 light-years above and below the Milky Way's plain cosmic chimneys, spewing high-energy gamma rays. Discovered in 2010 by NASA, a Fermi Gamma-Ray Space Telescope, these colossal structures glow with the energy of 100,000 supernova, yet they're invisible to the naked eye. Imagine holding a snow globe, shaking it violently, and watching the glitter swirl into two perfect domes. That's essentially what's happening at galactic scales, except the glitter is deadly radiation, and the force behind it remains one of modern astronomy's fiercest debates. The leading suspect, our galaxy's supermassive black hole, Sagittarius, a star which may have gone on a feeding frenzy millions of years ago. When black holes devour too much matter at once, they can belch out titanic jets of particles traveling near light speed. These jets could have inflated the bubbles like cosmic balloons, leaving behind a lingering glow of gamma rays. Supporting this theory are faint X-ray echoes near the bubble's edges, ghostly shockwaves hinting at an ancient cataclysm. But there's a twist. Some models suggest the bubbles are too symmetrical for a chaotic black hole outburst. Their smooth, sharp edges point to a more sustained energy source, like the annihilation of dark matter particles colliding in the galactic core. If true, these bubbles could be our first glimpse of dark matter's hidden interactions, a shadow universe revealing itself through gamma-ray whispers. What's undeniable is their impact. The bubbles act like a pressure cooker for cosmic rays, accelerating particles that could influence star formation across the Milky Way. They're also rewriting our understanding of galactic ecology. Most galaxies were thought to evolve slowly, like trees growing over centuries, but the Fermi bubbles prove that violent, sudden events can reshape entire systems in cosmic blink. Here's what keeps astronomers awake. The bubbles are young by galactic standards, perhaps just a few million years old. That means whatever created them might not be done yet. Could Sagittarius, a star, be gearing up for another eruption? Is dark matter clustering in new ways we can't predict? The answers might be written in those faint gamma rays, a message from the galaxy's violent heart waiting to be decoded. Somewhere beyond the edge of everything we can see, something immense is pulling. Not just stars or galaxies, but entire clusters of galaxies, thousands of them, streaming in the same direction at speeds that defy logic. This is the dark flow, one of cosmology's most unsettling mysteries. Imagine throwing confetti into the air, only to watch every piece drift toward the same invisible corner of the room. That's what astronomers observed when they studied the motion of galaxy clusters, their trajectories aligned like iron filings drawn to a hidden magnet. The discovery came from analyzing the cosmic microwave background, the afterglow of the Big Bang. Tiny temperature fluctuations in this radiation should be random, like static on an old TV. But when scientists mapped them, they found a startling pattern. Galaxy clusters moving en masse toward a single point in the sky, as if tugged by something colossal beyond our observational horizon. The scale is staggering. These clusters are racing at nearly 1,000 kilometers per second toward an attractor we can't see, can't measure, and can't even confirm exists. Skeptics argue it could be an artifact of incomplete data or measurement errors. After all, the cosmic microwave background is faint, and parsing its subtleties is like listening for a whisper in a hurricane. Some suggest uneven distribution of matter in the early universe might have left gravitational imprints that resemble motion. But here's the problem: the dark flow persists even when accounting for these variables. The signal is too strong, too coherent to dismiss as noise. This is where theories get wild. One possibility: the dark flow is evidence of a neighboring universe, a parallel cosmos lurking just beyond the edge of our own, its gravity leaking into our space-time like sound through a wall. In multiverse scenarios, colliding bubble universes could create gravitational imbalances, dragging matter toward unseen masses. It's a radical idea, but the math holds. If another universe brushed against ours during inflation, the cosmic tug-of-war might still be playing out. Others propose something even stranger, that the flow points to pre-Big Bang structures, remnants of an earlier epoch that somehow survived the birth of our universe. Picture a shoreline shaped by tides that vanished millions of years ago. The dark flow could be the imprint of a gravitational tide from a time before time. What's undeniable is this: the dark flow challenges our most basic assumption about the universe, that matter should be evenly distributed on large scales. If confirmed, it means there's something out there so vast, so alien, that it bends the cosmos on scales we've never dared to imagine. And that realization doesn't just rewrite the textbooks, it tears them up entirely. Hidden in the depths of space, glowing like celestial jellyfish, Lyman alpha blobs are among the most mysterious structures ever observed. Enormous clouds of hydrogen gas, some stretching hundreds of thousands of light years, radiating an eerie ultraviolet glow. Named after the specific wavelength of light they emit, these blobs are cosmic relics left over from the universe's youth when galaxies were just beginning to form. But here's the puzzle: they shouldn't be this bright. The hydrogen in these clouds gets excited by some unknown energy source, causing it to fluoresce like a neon sign across the cosmos. The leading theory: baby galaxies forming inside these blobs, their newborn stars flooding the surrounding gas with radiation. Imagine a foggy night where streetlights appear as hazy halos, except here, the streetlights are entire galaxies, and the fog is primordial hydrogen from the dawn of time. Some blobs even show signs of supermassive black holes at their cores, their jets pumping energy into the gas like cosmic blowtorches. Yet in many cases, the glow is too uniform, too widespread to be explained by visible galaxies alone. Could dark matter be playing a role, or are we seeing echoes of ancient quasars, their light long faded but their energy still rippling through the gas? Now shift gears to Alcyone, a galaxy so vast it makes the Milky Way look like a backyard pond, stretching an incomprehensible 16 million light-years from end to end. This giant radio galaxy's jets blast outward like titanic searchlights, fueled by a supermassive black hole with an appetite for destruction. What's astounding isn't just its size, but what it implies about the limits of galactic growth. Conventional wisdom says jets like these should fizzle out after a few million light-years, their energy dissipating into the void. But Alcyonius laughs at those limits. Its jets persist, carving through intergalactic space like a cosmic icebreaker, leaving astronomers scrambling to explain their endurance. One clue lies in the environment. Alcyonius sits in a particularly sparse region of the universe, where the intergalactic medium is thin like a ship sailing through calm waters instead of a stormy sea. Without much resistance, its jets can travel farther than expected, but even that doesn't fully account for their staggering length. Some propose the black hole at its core has been active for an unusually long time, gorging on gas without interruption. Others wonder if Alcyonius is tapping into something darker, an invisible reservoir of energy we've yet to understand. Together, these two structures paint a picture of a universe far more dynamic than we imagined. The Lyman alpha blobs show us the delicate dance of gas and light in the early cosmos, while Alcyonius pushes the boundaries of how large a single galaxy's influence can grow. They're reminders that even the faintest, most diffuse structures hold secrets, and sometimes the biggest enigmas come in the quietest whispers or the most relentless echoes. Saturn's North Pole hides a secret so geometrically perfect, it looks like nature took a compass to the sky. A colossal hexagon 25,000 kilometers wide, each side longer than Earth's diameter, spins with military precision, wrapping the planet's pole in a six-sided hurricane. This isn't some trick of perspective or camera artifact. For over 40 years since Voyager first glimpsed it in 1980, the hexagon has remained locked in place, a rotating puzzle etched into Saturn's atmosphere. And here's the kicker, nothing else like it exists in the solar system. Theories about its origin read like a physicist's fever dream. On Earth, weather systems swirl chaotically, their shapes fleeting. But Saturn's hexagon behaves like a standing wave, its six sides crisp as a freshly drawn hexagram. The leading explanation points to deep-rooted jet streams moving at different speeds, creating shear forces that carve the gas into geometric stability. Picture wind speeds hitting 500 kilometers per hour, colliding like cosmic traffic jams, and somehow against all odds settling into this perfect symmetry. Laboratory experiments with spinning fluids have recreated crude polygonal shapes, but never with the hexagon's eerie precision. What makes this structure even stranger is its longevity. Storms on Jupiter's poles come and go. Neptune's great dark spot vanished after a few years, yet Saturn's hexagon persists unchanged through decades of observation, as if someone hit pause on atmospheric turbulence. Some researchers speculate it's anchored by deep planetary rotation, a fundamental resonance between Saturn's interior and its atmosphere. Others wonder if the hexagon is a shadow of something deeper, a hidden structure beneath the clouds, warping the weather patterns above like an invisible hand. Then there's the wild card, electromagnetic forces. Saturn's magnetic field is oddly aligned with its rotation axis, unlike Earth's tilted field. Could charged particles high in the atmosphere be interacting with this field, sculpting the hexagon like iron filings arranging themselves around a magnet? It's a fringe idea, but in a mystery this profound, no possibility can be dismissed. The hexagon's greatest lesson might be humility. For all our models and supercomputers, nature still crafts patterns we can't fully replicate. It's a reminder that even in our own cosmic backyard, the universe keeps secrets, whispering them in jet streams, painting them in polar storms, and daring us to look closer. Every time we think we've unraveled the rules, Saturn spins its hexagon like a cosmic sigil, proof that some answers stay just out of reach. On the night of August 15, 1977, a radio telescope in Ohio picked up a signal so bizarre, the astronomer who found it scribbled, "Wow." In the margin of the printout and changed history, For 72 seconds, a narrowband radio burst from the constellation Sagittarius blazed at 50 times the background noise, hitting exactly the frequency hydrogen emits in deep space. Then, just as suddenly, it vanished. No natural phenomenon we know of behaves this way. Stars don't blink on and off like cosmic lighthouses. Pulsars don't transmit on one perfect frequency. This wasn't static or satellite interference, it was a shout in the void, and we've never heard anything like it since. The mystery begins with the signal structure. Locked at 1420 MHz, the hydrogen line, it matched predictions for how an advanced civilization might broadcast its presence. Hydrogen is the most abundant element in the universe, a universal landmark any intelligent species would recognize. The signal also exhibited a telltale Doppler shift, rising and falling in intensity as if scanning past the telescope's field of view. Imagine someone swinging a flashlight beam across your window. That's the kind of precision we're talking about. Decades of follow-up searches have turned up nothing. The Allen Telescope Array, built specifically to revisit the WOW region, has scanned it hundreds of times. Not a blip. Even the most exhaustive sky surveys like Breakthrough Listen have found no repeats. This silence fuels two competing theories. The natural camp argues for a one-off event, perhaps a comet's hydrogen cloud glowing briefly as it crossed the telescope's beam. But here's the catch. No known comet was in that exact patch of sky that night. Others suggest an exotic astrophysical event, like a neutron star's magnetic hiccup or interstellar plasma focusing a distant signal like a lens. Then there's the unnerving possibility. What if it was artificial, not necessarily a deliberate message, but maybe a leakage from some colossal alien engineering project, a power beam for light sails, or a radar sweeping the cosmos? The signal's brevity fits the profile of a transient emission, something not meant to be heard. If that's true, the WOW signal might be our first and only brush with intelligence beyond Earth, a single postcard from a civilization that could be long gone. Its legacy is undeniable. The WOW signal became SETI Rosetta Stone, proving that narrowband radio searches could work. It inspired generations of astronomers to keep listening, even as the cosmic silence deepened. And it taught us a humbling lesson. The universe doesn't owe us answers on our timeline. That 72-second burst might remain a mystery for centuries, or until, somewhere in Sagittarius, someone decides to shout again. The Red Rectangle Nebula doesn't play by the rules of cosmic beauty. While most nebulas sprawl across space in ethereal swirls of color, this one looks like it was drafted with a protractor, a near-perfect X-shape framed by crimson beams, glowing against the blackness like some celestial warning sign. At its heart lies HD 44179, a dying binary star system pumping out layers of carbon-rich dust so thick, they've sculpted the surrounding gas into one of the most geometric structures ever observed. This isn't just a pretty accident. The nebula's sharp angles defy everything we know about how dying stars shed their material. Normally, aging stars eject gas in spherical shells or chaotic bursts. But HD 44179's binary dance, two stars orbiting so close they're nearly touching, twists that process into something extraordinary. As one star bleeds material, its companion's gravity whips the outflow into twin cones like water spiraling down a drain. Over millennia, these cones have aligned almost precisely edge-on from our viewpoint, creating that uncanny X. Even the color is a rebellion. Most nebulas glow blue from ionized oxygen or pink from hydrogen. The red rectangle's crimson hue comes from an exotic form of carbon dust, molecules so rare they're nicknamed red organic gunk by astronomers. But the real magic happens at the X's crossroads. High-resolution images reveal a series of ladder-like rungs between the beam's concentric rings of dust, stacked like a cosmic phonograph record. These are thought to be pulses of material ejected every few hundred years, frozen in time like tree rings. Each one captures a snapshot of the star's death throes, a slow-motion explosion we're seeing from the front row. The unsettling perfection of this structure raises bigger questions. Could binary stars be cosmic sculptors more often than we realize? Are there other geometric nebulas hiding in plain sight, their shapes invisible until viewed at just the right angle? And most tantalizing of all, if carbon-rich molecules thrive here, could they be seeding the building blocks of life elsewhere? The red rectangle doesn't just defy expectations, it hands us a blueprint for how chaos can create order, written in dust and light. At the heart of our galaxy, hidden behind thick curtains of dust and starlight, lurks a sleeping giant Sagittarius, a star, the supermassive black hole anchoring the Milky Way. Clocking in at 4.3 million times the mass of our Sun, this cosmic monster should be a raging inferno, devouring stars and belching jets of plasma like its counterparts in other galaxies. Instead, it's eerily quiet, flickering with occasional, unexplained flares that leave astronomers scratching their heads. Take those mysterious X-ray and infrared eruptions, for instance. Every few hours or days without warning, Sagittarius, a star's brightness can spike by up to 100 times before fading back into obscurity. It's as if someone's turning a cosmic dimmer switch on and off at random. The leading theory, chaotic feeding habits. Unlike orderly black holes that swallow gas in steady streams, ours might be dining on clumps of falling material, asteroids, rogue planets, or even chunks of disrupted stars, causing brief, violent bursts of radiation as each morsel gets torn apart. Some flares even show bizarre quasi-periodic oscillations, pulsing with rhythms that could hint at materials swirling at light speed just outside the event horizon. Then there's the puzzle of its spin. Is Sagittarius a star rotating lazily, or is it a frenetic cosmic top nearing maximum speed? Measurements are all over the place. Some studies using X-ray echoes suggest it's spinning at about 10% of its theoretical limit, while others analyzing jet remnants argue it's closer to 90%. This isn't just academic. A black hole's spin encodes its history. Fast rotation implies a violent past, perhaps gorging on entire galaxies during collisions. Slow spin suggests gradual growth, like a patient predator. Yet our galaxy's center defies easy categorization, offering contradictory clues like a crime scene where the evidence keeps changing. What really baffles scientists is its silence. Compare Sagittarius, a star, to M87's black hole, the first ever imaged, which launches a jet 5,500 light-years long. Our black hole's jets, if they exist at all, are pitifully faint, barely a whisper against the galactic background. One explanation is diet. Maybe there's just not enough gas falling into it to fuel fireworks. But even that feels unsatisfying. Observations reveal plenty of material orbiting nearby, including a bizarre population of stars zipping around like moths near a flame. Why isn't it feeding more aggressively? The answer might lie in black hole weather. Recent simulations suggest magnetic fields near Sagittarius, a star, could act like atmospheric pressure, deflecting incoming gas like wind pushing sailboats off course. Or perhaps past eruptions, evidence of which lingers in giant Fermi bubbles, cleared out its neighborhood, leaving it starved. There's even a fringe idea that dark matter interactions could be suppressing its activity, an invisible hand keeping the beast dormant. Every flicker, every flare from this sleeping giant is a coded message. Deciphering it could rewrite not just the story of our galaxy, but of how all supermassive black holes evolve. For now, Sagittarius, a star, sits in quiet rebellion, a king that refuses to rule, a furnace that barely burns, reminding us that even the darkest hearts of galaxies keep secrets we've only begun to unravel. We live in the quietest neighborhood in the universe, and that's the problem. Nestled inside the KBC void, an enormous bubble of relative emptiness stretching over 2 billion light-years across, our Milky Way floats in a region where galaxies are conspicuously sparse. Named after astronomers Keenan, Barger, and Cowie, who identified it in 2013, this void isn't just another cosmic desert. It's a direct challenge to one of cosmology's most fundamental assumptions, that the universe is smooth and homogeneous on large scales. Here's the catch: our standard models predict galaxies should be distributed like sprinkles on a cupcake, roughly even no matter where you look, but the KBC void flips that idea on its head. Inside this underdensity, matter is 20% scarcer than the cosmic average. That might not sound dramatic until you realize the sheer scale. If this void were a building, it would make the Burj Khalifa look like a Lego block. And our solar system, we're sitting somewhere in the basement, oblivious to the emptiness around us. This isn't just a curiosity, it's feeding one of modern astronomy's fiercest debates, the Hubble constant tension. That's the growing discrepancy between how fast we think the universe is expanding versus what we actually observe. Local measurements using supernova and Cepheid variables give one value for the expansion rate, while predictions based on the cosmic microwave background give another. The numbers should match, but they stubbornly refuse. The KBC void might hold the key. Living inside such a vast underdensity could be skewing our local measurements without us realizing it. Think of it like standing in a valley and trying to judge the terrain of the entire planet. Your perspective is inherently warped. Gravity behaves differently here, with less matter pulling on galaxies nearby, potentially making them appear to recede faster than they truly are. Some theorists argue this could account for up to half the discrepancy in the Hubble constant, but not everyone's convinced. Critics point out that voids this large are statistically improbable in our current simulations, like finding a single grain of sand in an Olympic-sized swimming pool. If the KBC void is real, it might mean our models of cosmic structure formation are missing something critical, perhaps new physics or exotic dark energy behavior. Others propose an even wilder idea, that we're seeing the imprint of an ancient collision with another universe, a gravitational bruise left over from before time began. What makes this void uniquely unsettling is its intimacy. Unlike distant anomalies we observe from afar, this one cradles us. It's the cosmic equivalent of waking up to find your house floating in the middle of a silent, empty plain with no explanation. Whether it reshapes our understanding of the universe's expansion or forces us to rewrite the rules of structure formation, the KBC void isn't just out there, it's home. And that means the greatest cosmic mystery might not lie in some far-off galaxy, but right outside our galactic doorstep. Embedded in the afterglow of the Big Bang like a cosmic bruise, the CMB cold spot is one of the most puzzling anomalies ever detected in our universe's baby picture. Stretching nearly 1.8 billion light-years across, this region in the constellation Eridanus is significantly colder than its surroundings, by about 70 microkelvins, a discrepancy that sounds trivial until you realize the cosmic microwave background is uniform to 1 part in 100,000. This isn't just statistical noise, it's a screaming outlier, a place where the universe forgot to follow its own rules. The mystery deepens when you consider what should be there. According to standard cosmology, such large temperature fluctuations are virtually impossible under the inflationary model. The cold spot's size and chilliness make it a statistical unicorn, something so rare it challenges our understanding of how matter clumped together in the early cosmos. One theory suggests it's the imprint of a supervoid, an enormous bubble of underdense space where fewer galaxies mean less gravitational pull, causing light passing through to lose energy and appear colder. But here's the catch: surveys like the Dark Energy Survey found no void large enough to explain the cold spot scale. The absence of a visible culprit makes this cosmic cold case even stranger. This is where the explanations get wild. Some theorists propose the cold spot could be evidence of a collision with another universe during the chaotic moments of cosmic inflation. Picture two soap bubbles bumping in a sink. If another bubble universe grazed ours, the energy transfer might have left a temperature anomaly in the CMB, like a gravitational fingerprint. Others suggest even more exotic physics, like cosmic textures, hypothetical defects in spacetime itself, relics from when the fundamental forces of nature split apart in the universe's first moments. These textures would distort spacetime like wrinkles in a tablecloth, potentially creating regions of unusual cooling. Then there's the unsettling possibility that the cold spot isn't an anomaly at all, but a sign that our assumptions about the universe's isotropy are fundamentally flawed. What if the cosmos isn't as uniform as we think? The cold spot might be the first thread we've pulled in a much larger tapestry of cosmic irregularities, hinting at physics beyond our current models. Every time we point our telescopes at this enigmatic patch of sky, it whispers the same tantalizing question: are we seeing a cosmic accident, evidence of a multiverse, or something even stranger? The cold spot refuses to fit neatly into any box, and that's precisely what makes it one of the most compelling mysteries on the edge of known physics. It's not just a cold patch, it's a window into everything we don't yet understand. Amidst the cosmic sprawl of ancient galaxies and quiet giants, there exist tiny, frenetic powerhouses no bigger than a fraction of our Milky Way, yet blazing with the energy of a stellar fireworks show. These are the green pea galaxies, named for their small, round shapes and vivid emerald hue in telescope images, a color born from their intense bursts of star formation. Discovered in 2009 by citizen scientists combing through data from the Sloan Digital Sky Survey, these compact galaxies pump out new stars at rates hundreds of times faster than our own galaxy, flooding their surroundings with ultraviolet radiation that lights up surrounding gas like neon signs. What makes them cosmic Rosetta Stones is their eerie resemblance to the earliest galaxies in the universe. Their chemical makeup, low in heavier elements like oxygen and iron, mirrors conditions billions of years ago when the cosmos was just learning how to build stars. It's as if we've stumbled upon living fossils, pockets of the primordial universe frozen in time. But the real surprise, their feedback loops. The violent stellar winds and supernova from their star-forming frenzy eject material at staggering speeds, clearing vast bubbles around them. This self-regulation, where stars both create and destroy the conditions for further star birth, may solve a long-standing riddle: how the first galaxies avoided choking on their own exhaust, preventing their gas from collapsing into new stars too quickly. Now meet their bizarre cousins, the voorwerps, Dutch for little objects. These eerie, glowing clouds of ionized gas float near galaxies like cosmic jellyfish, untethered by gravity yet blazing with energy. The twist, they're lit up by beams of radiation from supermassive black holes that have since gone quiet, light echoes of ancient galactic fury. Imagine a flashlight beam hitting a wall long after the battery has died, and you've captured the essence of a voorwerp. The most famous Hanny's voorwerp was discovered by a schoolteacher participating in the Galaxy Zoo project, its ghostly glow revealing the shadow of a quasar that shut off tens of thousands of years ago. Together, green peas and voorwerps paint a dynamic picture of cosmic evolution. The peas show how small galaxies can punch above their weight, seeding the universe with heavy elements and radiation. The voorwerps, meanwhile, serve as tombstones for black hole activity, proving that even the most violent engines can flicker out, leaving behind only whispers in the gas they once tormented. They're proof that the universe doesn't just build and destroy, it leaves clues in the faintest glows and the greenest sparks waiting for us to decode their stories. 55 light-years from Earth, orbiting a star visible to the naked eye, floats a world that turns the concept of wealth upside down. 55 Cancri E isn't just another exoplanet, it's a cosmic jewel box, a super-Earth so rich in carbon that scientists speculate vast layers of its interior could be compressed into diamond. Imagine a planet where mountains might literally glitter, where the crust could crack under the weight of its own crystalline luxury. But this isn't some celestial fairy tale. It's a nightmare of extremes that defies everything we thought we knew about how planets form. First, the numbers: twice Earth's width and nearly 9 times its mass. 55 Cancri whips around its sun-like star in just 18 hours, so close that its surface temperature could melt iron. Telescopes have detected no atmosphere to speak of, just a broiling wasteland where temperatures hit 2,700 degrees Celsius on the dayside. Yet the real shock came when astronomers analyzed the star it orbits. The parent star is carbon-rich, suggesting the planet formed from material heavy in carbon instead of the oxygen and silicon that dominate Earth's composition. In such a high-pressure, high-heat environment, carbon crystallizes into diamond. Simulations suggest at least a third of the planet's interior, hundreds of times more mass than all of Earth's diamonds combined, could exist in this form. But here's where the mystery deepens. Planets like this shouldn't exist so close to their stars. In our solar system, carbon-rich bodies like asteroids and comets lurk in the colder outer reaches. Conventional wisdom says heat and radiation near a star should vaporize lighter elements, leaving behind rocky worlds rich in heavier materials like Earth. 55 Cancri turns that logic inside out. One theory suggests it might be the remnant core of a gas giant whose atmosphere was stripped away, leaving behind a carbon-heavy skeleton. Others propose it migrated inward from colder regions, dragging its diamond factories into the inferno. The most tantalizing question isn't just how it formed, but what happens to carbon under such extreme conditions. Lab experiments show that under immense pressure, diamond can behave like a metal, conducting electricity or even melting into a sea of carbon ions. On 55 Cancri, entire oceans of liquid carbon might slosh beneath diamond icebergs, with carbon vapor potentially raining back down in a hellish cycle. This planet isn't just a curiosity, it's a portal. Its existence proves that the universe crafts worlds from recipes we've never tasted, in ovens we're only beginning to understand. Every shimmering layer of diamond, every scorching gust of carbon wind whispers the same lesson. Out there, the rules are waiting to be rewritten. Some stars flicker, but none like KIC 8462852, better known as Tabby's star. This unassuming point of light in the constellation Cygnus behaves like no other sun in the cosmos, dimming erratically by up to 22% without warning or pattern. Most stars dip slightly when planets pass in front of them, but Tabby's star doesn't play by those rules. Its light curves resemble a cosmic cardiogram gone haywire, sharp, asymmetrical drops that last days or weeks, then rebound as if nothing happened. The mystery began in 2015 when citizen scientists analyzing Kepler Space Telescope data flagged the star's bizarre behavior. Initial theories pointed to swarms of comets, hundreds of thousands of them, eclipsing the star in chaotic succession. But that explanation quickly unraveled. Comets couldn't account for the star's long-term fading. Observations dating back to the 1800s show its overall brightness has dropped by nearly 20% over the past century. Nothing in known astrophysics explains that kind of sustained dimming without leaving obvious traces in the star's spectrum. Then came the wild card, the Dyson swarm hypothesis. Physicist Freeman Dyson once theorized that advanced civilizations might build massive structures around stars to harvest their energy, think solar panels on a cosmic scale. Could the irregular dimming be evidence of such a megastructure under construction? The idea wasn't entirely fringe. Even astronomers at SETI trained their radio telescopes on Tabby's star, searching for signals amid the noise. But years of scrutiny turned up no technosignatures, no telltale radio pulses, just that maddening, unpredictable flicker. Recent observations have only deepened the puzzle. In 2021, the star dimmed dramatically again, but this time telescopes caught it in unprecedented detail. The data revealed something unexpected. The dimming events weren't uniform. Some wavelengths of light were blocked more than others, ruling out solid megastructures in favor of something far dustier. Current frontrunner theories now involve vast rings of fine particles, possibly from a disintegrating moon or a recent planetary collision, scattering starlight in unpredictable ways. Yet even dust can't explain everything. Why does the star's long-term fading continue? Why do some dips last weeks while others vanish in hours? The more we study Tabby's star, the clearer it becomes. This isn't just an unsolved mystery. It's a cosmic masterclass in how much we still don't know. Every flicker, every unexplained dip, is a reminder that the universe has more tricks up its sleeve than we've dared to imagine. And that's what makes this star so extraordinary. It refuses to be ordinary. Dragonfly 44 hangs in the Coma cluster like a cosmic ghost, a galaxy the size of the Milky Way, yet so faint it was only discovered in 2015. At first glance, it appears broken, a failed experiment in starlight. While our galaxy blazes with 100 billion stars, Dragonfly 44 flickers with just 1% of that number, scattered so thin they barely cast shadows. But here's the twist. This wispy phantom weighs just as much as the Milky Way. The missing mass, dark matter, so much that this galaxy is 99.99% invisible, a celestial mirage held together by the universe's most elusive substance. How does a galaxy fail this spectacularly? One theory suggests Dragonfly 44 is a pure dark matter halo, a pocket of the early universe where gas simply never cooled enough to form many stars. Imagine a cloud of hydrogen floating through a cosmic freezer, but someone left the door open. The gas stayed too warm to condense into stellar nurseries. Another idea paints a darker picture. Perhaps it was once a normal galaxy until eons of gravitational harassment by neighboring galaxies ripped away its stars and gas, leaving behind a skeleton of dark matter like a shipwreck stripped by tides. Supporting this is the galaxy's bizarre globular clusters. While the Milky Way has about 150, Dragonfly 44 boasts nearly 100, far more than its handful of stars should warrant. These dense knots of ancient stars might be the last survivors of a violent past, clinging to the galaxy's dark matter scaffold like barnacles on a sunken hull. For dark matter hunters, Dragonfly 44 is a gold mine. Its extreme ratio of dark to visible matter lets scientists test theories with minimal interference from stars or gas. Already, its existence has challenged models. Standard dark matter simulations struggle to produce such massive, star-poor galaxies naturally. Some researchers propose alternative forms of dark matter, like fuzzy or warm dark matter, which could explain how these ghostly giants form. Others see them as cosmic missing links, evidence that dark matter halos can exist almost entirely empty, waiting in the shadows for a future collision to ignite them with new stars. The most haunting question isn't how Dragonfly 44 formed, but how many more like it are out there. Current telescopes can only spot the nearest and largest dark galaxies. Future instruments like the James Webb Space Telescope might reveal legions of these phantoms, rewriting the cosmic census. They could be the universe's silent majority, a hidden network of dark matter islands where the rules of galaxy formation play out in whispers rather than fireworks. Dragonfly 44 isn't just a curiosity, it's a key to the invisible architecture of the cosmos, a reminder that what we see is only the faintest echo of what's truly there. At the heart of the Virgo cluster, a cosmic titan feasts in silence. Messier 87 isn't just any galaxy. It's a gravitational predator, a cannibal that spent billions of years devouring its neighbors. This supergiant elliptical galaxy stretches nearly 120,000 light-years across, but its true scale becomes horrifying when you realize what it's made of: the mangled remnants of countless smaller galaxies, torn apart and digested into its glowing halo. And at its core lies the most famous black hole in history, the first ever directly imaged by humanity, a monster weighing 6.5 billion suns. The iconic orange ring of light captured by the Event Horizon Telescope in 2019 revealed more than just a celestial singularity. That glowing accretion disk, bending light like a cosmic funhouse mirror, is the signature of a black hole that's grown fat on galactic flesh. Messier 87's central black hole didn't reach this staggering size by nibbling on gas clouds. It gorged itself during the galaxy's relentless mergers. Telescopes have traced streams of stars stretching hundreds of thousands of light years from its core, the gravitational scars of ancient collisions. One particularly gruesome trail, dubbed the Southern Jet, contains stars moving at nearly light speed, souvenirs from a dwarf galaxy torn apart and hurled into the void. What makes Messier 87 so terrifyingly efficient is its environment. Nestled in the dense Virgo cluster, it swims in a sea of potential victims. Smaller galaxies passing too close get caught in its gravitational web, their stars slowly stripped away in tidal streams that glow like cosmic breadcrumbs. Some spiral galaxies have had their gas ripped away entirely, transformed into red and dead husk zombie galaxies still orbiting their killer. And the black hole's jets, visible across 5,500 light-years of space, act like cosmic blowtorches, preventing new stars from forming in the consumed gas, ensuring nothing interrupts its feast. This relentless consumption holds clues to one of astronomy's biggest mysteries: how supermassive black holes grow so large so quickly. Messier 87 suggests the answer isn't steady feeding, but violent buffets, galactic mergers that funnel entire rivers of stars and gas into the maw. Simulations show that without these mergers, even the greediest black holes would starve long before reaching billions of solar masses. The black hole's spin, measured from that historic image, supports this. It's aligned with the galaxy's rotation axis, as if the last major meal sent it spinning like a top. Yet the most haunting implication lies in our own future. The Milky Way and Andromeda are destined to collide in 4 billion years, potentially creating a Messier 87 clone. Will our supermassive black hole merge with Andromeda's, creating an even larger monster? And what happens to planetary systems when galaxies cannibalize each other? Messier 87 doesn't just show us the past, it's a preview of the universe's inevitable feast, where only the hungriest giants survive. Far beyond our galactic neighborhood, two cosmic titans are rewriting the rulebook on how the universe builds and destroys its largest structures. First up is El Gordo, the Fat One in Spanish, a galaxy cluster so massive it bends the fabric of reality itself. Clocking in at a staggering 3 quadrillion times the mass of our Sun, this behemoth in the constellation Phoenix holds the record for the most massive known object in the early universe, a title it earned by cramming hundreds of galaxies into a space just 20 million light-years across. But here's what makes El Gordo truly terrifying. It's not one cluster, but two, caught in the act of a collision so violent it's ripping spacetime apart at the seams. X-ray observations reveal a shockwave of 100 million-degree gas stretching over 6 million light-years, like a cosmic tsunami frozen in mid-crash. And yet, something doesn't add up. According to standard cosmology, structures this massive shouldn't have had time to form when the universe was just half its current age. El Gordo is essentially a cosmic teenager bench pressing twice its expected weight, and astronomers are scrambling to understand how it got so strong so fast. Now meet its equally spectacular counterpart, the Bullet Cluster, a cosmic crime scene 1.2 billion light-years away where forensic evidence for dark matter was first captured. When these two galaxy clusters collided, something extraordinary happened. The visible matter, stars and glowing gas, behaved exactly as you'd expect in a high-speed wreck. The gas clouds smashed together like celestial fenders crumpling, creating an arc of X-ray emissions visible in blue. but the real shock came when astronomers mapped the cluster's mass using gravitational lensing. The bulk of the weight wasn't where the visible crash occurred. It had sailed ahead in two distinct clumps, revealed by the warped light of background galaxies. This was the smoking gun. Dark matter, making up 85% of the cluster's mass, had passed right through the collision unaffected, like ghosts walking through walls. The bullet cluster didn't just suggest dark matter exists, it handed us the first direct observational proof, separating the invisible scaffolding of the universe from the ordinary matter we can see. What makes these clusters such perfect cosmic foils is how they showcase opposite extremes of the dark matter mystery. El Gordo's unbelievable heft hints at dark matter's role as the universe's ultimate architect, gathering enough mass to build record-breaking structures impossibly early. The bullet cluster, meanwhile, demonstrates dark matter's ghostly indifference to everything but gravity. It neither collides, slows, nor interacts with itself or normal matter. Put them together, and you've got the most compelling case yet for dark matter's existence, written in the wreckage of colliding worlds. These aren't just clusters, they're cosmic time capsules, preserving moments when the invisible hand shaping our universe briefly stepped into the light. In 2020, radio telescopes scanning the sky stumbled upon something no one expected: enormous, perfectly circular rings of radio emission, each spanning hundreds of thousands of light years. These odd radio circles, or ORC, appeared on scans like cosmic smoke rings, floating in the void with no obvious source. Unlike anything seen before, they don't correspond to visible galaxies or known supernova remnants. Some are even large enough to swallow entire galaxies whole. The discovery sent astronomers scrambling for explanations, because in a universe where most structures are messy and asymmetrical, ORCs are unnervingly precise. The leading theory suggests these rings might be shockwaves from colossal galactic mergers. Imagine two galaxies colliding with such force that they send ripples through the surrounding intergalactic gas, lighting it up like a neon sign. When supermassive black holes at the centers of merging galaxies spiral toward each other, they can unleash titanic bursts of energy, potentially creating spherical shockwaves that expand outward. But there's a problem. ORCs are far larger and more symmetrical than any known merger remnants. They also lack the X-ray or infrared signatures typically left by such violent events. It's like finding a perfectly circular crater in the desert with no trace of the meteor that made it. Another possibility ties ORCs to the death throes of quasars. When these ultra-bright galactic cores shut down, their jets might leave behind expanding bubbles of radio emission, fading over millions of years. Yet again, the scales don't quite match. ORCs are too uniform, too isolated. Some researchers have even floated the idea of wormholes, theorizing that these rings could be the mouths of Einstein-Rosen bridges, their extreme gravity bending space-time into a visible ring. While intriguing, this remains firmly in the realm of speculation, as no known physics predicts wormholes leaving such clean radio imprints. What makes ORCs truly bizarre is their selectivity. They glow brightly in radio waves but are virtually invisible in other wavelengths. No stars, no gas, just eerie, empty halos of energy. One ORC even has a galaxy at its center, but the galaxy appears perfectly ordinary, with no signs of the violent activity needed to produce such a structure. It's as if the universe pressed a giant cookie cutter into the fabric of spacetime and left behind these ghostly outlines. Every new observation deepens the mystery. Recent studies suggest ORCs might be far more common than we thought, lurking undetected in older radio surveys. Future telescopes, like the Square Kilometre Array, could reveal whether these circles are rare cosmic accidents or part of a hidden population rewriting the rules of galactic evolution. For now, they stand as silent sentinels, challenging us to look deeper, because in a universe full of chaos, perfection is the ultimate anomaly. At the frozen edges of our solar system, where sunlight is a dim memory and the pull of distant stars begins to rival the sun's, there's a tiny world with an orbit so extreme it shouldn't exist. Meet the Goblin, officially known as 2015 TG387, a dwarf planet smaller than Ireland, discovered in 2015 lurking 80 astronomical units from the Sun. That's 80 times farther than Earth, so distant it takes 40,000 years to complete a single, lopsided loop around our star. But the real shock isn't its distance, it's the Goblin's bizarre path, a stretched ellipse that catapults it over 2,000 astronomical units away at its farthest point, deep into the hypothetical Oort cloud. This isn't just another icy rock. The Goblin's orbit is a cosmic breadcrumb pointing to something far larger lurking in the dark. Like a handful of other extreme trans-Neptunian objects, its trajectory clusters in a way that defies random chance, as if an unseen hand is nudging these worlds into similar orientations. That hand, according to leading theories, could be Planet 9, a hypothetical super-Earth up to 10 times more massive than our own, hiding in the outer solar system. The math is compelling. Simulations show that an undiscovered planet of that size could precisely sculpt orbits like the Goblin's, herding these distant worlds like a gravitational sheepdog. Yet the Goblin's true value lies in its timing. Discovered during a brief window when it was close enough to spot, this dwarf planet spends 99% of its life too faint for even our best telescopes. That means every other object like it we've found, Sedna, Biden, Lelicuhanua, represents a lucky snapshot of an otherwise invisible population. Together, they're rewriting the solar system's boundaries. The classical model, with Neptune as the outer edge and a sparse Kuiper belt beyond, now looks quaint. Instead, we're staring at a dynamic frontier where thousands of goblin-like worlds likely dance in the dark, their elongated orbits crisscrossing like strands of a vast cosmic spiderweb. What's truly mind-bending is the scale. If the Goblin's orbit were a dinner plate, Earth's would be a pea hovering near the center. At its farthest reach, the Sun would appear as just another bright star, and the temperature plunges near absolute zero. This raises spine-tingling questions. Could such worlds harbor underground oceans kept liquid by tidal heating, even in this frozen wasteland? Might their surfaces preserve pristine chemicals from the solar system's birth, untouched for billions of years? For now, the Goblin remains a tantalizing clue, a cosmic pendulum swinging between two possibilities. Either it's evidence of Planet 9's grip on the outer dark, or it's forcing us to invent entirely new physics to explain these clustered orbits without an unseen giant. Every new discovery in this realm stretches our solar system's story further into the unknown, proving that even in our own celestial backyard, the universe keeps its greatest secrets on a very, very long leash. The Goblin's ghostly orbit isn't just an oddity, it's a celestial breadcrumb trail, one of a handful of distant objects pointing toward a shadowy giant that might be lurking in our solar system's darkest reaches. Alongside worlds like Sedna and Biden, this icy dwarf planet moves in a way that defies the gravitational pull of known planets, tracing a path so elongated it suggests an unseen hand guiding it. The math is chillingly precise. The clustering of these extreme trans-Neptunian objects, all tilted in similar directions and swinging outward at comparable angles, has less than a 0.2% chance of being random. Something massive, perhaps 5 to 10 times Earth's mass, must be shepherding them. Enter Planet 9, the hypothetical titan that could rewrite our solar system's map. Unlike the whimsical predictions of astrologers or conspiracy theories, this idea comes from cold, hard orbital mechanics. Caltech astronomers Konstantin Batygin and Mike Brown calculated that such a planet, orbiting roughly 600 times farther from the Sun than Earth, could perfectly explain the Goblin's stretched path. Its gravitational influence would act like a cosmic conductor, aligning these distant worlds' orbits like compass needles pointing north, the kicker. This wouldn't be some tiny Pluto-like dwarf planet. We're talking about a true super-Earth, a missing link between terrestrial worlds and ice giants, one that might have been flung outward during the solar system's chaotic infancy. Yet finding Planet 9 is like searching for a black cat in a coal cellar. At such distances, even a large world reflects virtually no sunlight, and its motion across the sky would be glacially slow. Current surveys, like those conducted with Subaru telescope in Hawaii, scan slivers of the sky where the planet might hide, but it's a cosmic needle in a haystack challenge. That's where the Vera Rubin Observatory comes in. Set to begin operations in 2025, this groundbreaking facility will image the entire southern sky every few nights with a 3.2 billion pixel camera, spotting faint, slow-moving objects with unprecedented sensitivity. If Planet 9 exists and isn't currently hiding behind the glare of the Milky Way, Rubin's relentless gaze could finally corner it, but what if it's not there? Some theorists propose an even wilder alternative. Perhaps the orbital anomalies stem not from a planet, but from primordial black hole, a grapefruit-sized remnant of the Big Bang with Earth's mass. Others suggest collective gravitational tugs from smaller, undiscovered objects might mimic a single large perturber. Whatever the truth, the hunt for Planet 9 is more than a celestial scavenger hunt. It's a stress test for our understanding of the solar system's architecture. Every strange orbit, every clustered path is a clue, and the goblin might just be the first whisper of a revolution in our cosmic backyard. The longer the mystery lingers, the clearer it becomes. Our solar system story isn't finished. There are still pages hidden in the dark waiting to be read. But what if Planet 9 isn't a planet at all? The cosmic detective story doesn't end with a hidden super-Earth. Some theorists suggest we might be hunting a ghost. Imagine a black hole the size of a grapefruit, weighing as much as 5 Earths, lurking in the outer solar system. This isn't science fiction. It's a serious hypothesis that could explain the strange orbits of objects like the goblin without invoking an undiscovered planet. Primordial black holes, theoretical remnants from the universe's birth, could be scattered throughout space like invisible landmines. If one drifted into our solar system long ago, its gravitational pull might be sculpting those clustered orbits just as effectively as a planet would. The kicker, we'd never see it directly. Unlike planets, black holes this small wouldn't emit detectable radiation. They'd only betray their presence through their gravitational fingerprints on distant ice worlds. Yet even this dark horse theory has its skeptics. The odds of a primordial black hole crossing paths with our solar system seem astronomically slim, and there's no direct evidence such objects exist. But here's where things get clever. Astronomers have proposed hunting for this phantom using its predicted effects. As a black hole moves through space, its extreme gravity should slightly bend the light of background stars, an effect called microlensing. Projects like the Vera Rubin Observatory could scan the outer solar system for these telltale stellar flickers, turning the entire sky into a black hole detector. And if they find nothing, that silence would speak volumes, forcing us back to the drawing board. Then there's the contrarian perspective. What if there's no hidden perturber at all? Some scientists argue that the peculiar orbits of the goblin and its kin might stem from observational bias. Our telescopes simply haven't discovered enough distant objects to see the full, random distribution. It's like walking into a room and noticing 3 clocks all showing the same time. At first glance, it seems meaningful until you realize there are 20 other clocks you didn't spot, all displaying different hours. Simulations show that with a larger sample size of extreme trans-Neptunian objects, the apparent clustering might dissolve into statistical noise. This camp suggests we're being fooled by small numbers, weaving patterns where none exist. But the plot thickens when you consider the broader implications. If the gravitational anomalies aren't caused by Planet 9 or a black hole, and aren't just observational flukes, we might be staring at something far more revolutionary, a flaw in our understanding of gravity itself. Modified Newtonian dynamics, or MND, proposes that gravity behaves differently at galactic scales, no dark matter required. While MND struggles to explain all cosmic phenomena, some researchers wonder if the strange orbits of the outer solar system could be a local whisper of this larger mystery. Imagine if the universe handed us a Rosetta Stone for gravity's secrets, and we've been misreading it as a missing planet all along. The beauty of this cosmic whodunit lies in its uncertainty. Every few years, a new discovery, whether it's another oddball object like the Goblin or a fresh analysis of existing data, tilts the scales toward one theory or another. Right now, the outer solar system feels like a locked room mystery where each clue contradicts the last. Is the culprit a runaway planet, a relic black hole, a trick of incomplete data, or is the universe nudging us toward rewriting physics itself? Until we have definitive proof, these competing ideas don't just keep the mystery alive. They turn the hunt for Planet 9 into a living laboratory, testing the edges of our cosmic knowledge. And that's what makes this more than an astronomical curiosity. Whether we find a world, a shadow, or a revolution in physics, the answer will redefine our place in the cosmos. The outer dark isn't just hiding objects, it's guarding truths we haven't even learned to question yet. From ghostly galaxies made of dark matter to diamond planets burning in the void, these 25 cosmic anomalies share one glorious trait: they laugh in the face of our expectations. Every one of them, from the hexagon storm on Saturn to the invisible hand of the Great Attractor, exists as a rebellion against the textbooks, a reminder that the universe delights in shredding the rules we think we've written. They push against the limits of our technology, hiding in wavelengths we've only just learned to see, or lurking in distortions of gravity we're still struggling to measure. But more than anything, they teach us humility. For all our telescopes and supercomputers, the cosmos keeps its deepest secrets guarded behind veils of dust, distance, and dimensions we can't yet perceive. Think about it, Tabby's star flickers like a faulty light bulb, and we still can't agree why. The CMB cold spot hangs in the sky like a cosmic bruise, whispering of alternate universes or defects in spacetime itself. Even in our own solar system, the hunt for Planet 9 feels like chasing a shadow with a flashlight that's running out of batteries. These aren't just gaps in our knowledge, they're chasms, yawning wide enough to swallow every assumption we've ever made. And that's the thrill of it, because every time we think we've got the universe figured out, it tosses another enigma our way. A Lyman alpha blob glowing without a source, or an ORC floating in the void like a celestial smoke ring. So here's the real question: which of these cosmic rule breakers lingers in your mind? Is it the Great Attractor dragging us towards something unseen? The eerie perfection of Hoag's object, a galaxy that looks too precise to be real, or maybe the wow signal, that tantalizing 72-second shout we've never been able to explain? Drop your pick in the comments. I'd love to hear which mystery keeps you staring at the stars. And if you're hungry for more deep dives into the universe's strangest corners, hit subscribe, because the cosmos isn't done surprising us, not even close.